So EcoCar is one of the most prominent student competitions in the university space. Now in the K through 12 space, the most prominent competition is FIRST. And of course it wouldn't be a Day 3 keynote if I wasn't up here promoting FIRST. So last year, FIRST impacted over 200,000 children around the world, about 20,000 teams. They take advantage of our technology in all of their programs using NI Compact Rio, LabVIEW, and also the LabVIEW-based software that we developed for LEGO Mindstorms and LEGO WeDo. And I want to thank each of you who are involved in FIRST, whether you're mentoring a team or sponsoring your team, or perhaps one of the suppliers that donated equipment to us so that we could donate the controllers to all the FIRST robotics teams. And I also want to encourage each of you, if you're not involved with FIRST, please take advantage of your technical talents and your passion for science and engineering in considering being a part of the FIRST family. As Woody Flowers likes to say, it's the hardest fun you'll ever have. Now, FIRST stands for inspiration and recognition of science and technology. So what could be more inspiring than creating technology that makes it possible for a blind person to drive? Well, this team of students is putting new meaning into the phrase driving blind. Check it out.
Next January, preceding the Rolex 24, the first car drivable by the blind will be demonstrated at the Daytona International Speedway.
We have to build inside the machine a piece of technology that will let us perceive the exterior world. To accomplish our goal, the National Federation of the Blind will work in partnership with universities and technology manufacturers to combine our pioneering enterprise with their technical expertise to make the dream of a car drivable by the blind a reality.
In 2009, the National Federation of the Blind and Virginia Tech created the first prototype of a blind drivable vehicle.
It gives you freedom, and it really brings into reality that this could happen someday.
The blind drivable car is one of the most exciting opportunities to build new technologies to bring information to the blind that we have ever undertaken.
Please welcome from the Romella Lab, also from Virginia Tech, Dr. Dennis Hogg, Greg Janneman, and Kimberly Wenger. Hey, Dr. Hogg.
Yeah, very good. Thanks for having us. So you're probably already familiar with some of the very exciting robotics projects that we've been working on in Romella, the Robotics and Mechanisms Laboratory at Virginia Tech, such as the fully autonomous miniature humanoid robot, Darwin, that plays soccer. We just came back from Singapore, and I'm happy to announce that we won 3rd place and 4th place in RoboCup 2010. Thank you. And now the very famous Odin, the fully autonomous vehicle for the urban environment, where we teamed up with Torque Technologies, where we won $500,000 by placing 3rd place at the DARPA Urban Challenge. And besides that, we have many, many exciting robotics projects, all used National Instruments technology. However, today, we have something very different. As a matter of fact, I can probably call this a robotics project. So we call this project the Blind Driver Challenge. And we have developed the very first and only vehicle in the world that can be driven by the blind. So in 2007, NFB, the National Federation of the Blind, challenged the research community about who can develop a car that can be driven by the blind. So at the time, at Virginia Tech, we already had a fantastic research program in autonomous vehicles. So we thought, hey, we already have a vehicle. We just yank out the drive-by-wire system and a person inside there, and we're done, right? We couldn't be more wrong. So what NFB wanted was not a vehicle which can drive a blind person around, but a vehicle where a blind person can actually drive by making active decisions. So we had to start from scratch. So today, we would like to demonstrate some of the non-visual user interface technology that we developed for this project. And today we have Greg Janneman and Kimberly Wenger on stage. Greg?
Thanks, Dr. Hong. So in order to prove that a blind person can indeed safely operate a motor vehicle, you first need to demonstrate the ability to actually perform 3 fundamental driving tasks. The first of which is the ability to regulate their speed. Next is the ability to perform an emergency stop when necessary. And finally, to navigate through and maintain their position within a driving lane. Now, the first step in our system is to detect our environment. We do this using a laser rangefinder, or LiDAR. The LiDAR scans the environment ahead of us and replies with information based on the location of any obstacles that may be in our way. Now, we supplement the information from the LiDAR with additional data from additional sensors monitoring the vehicle state, things like steering angle and speed. We bring all that together, and it gives us a good understanding of where we are in our environment. Now, that's all great, but it's useless without a way to effectively and efficiently relay that information to the driver.
Now, we were able to relay that information to the driver using multiple non-visual driver interfaces. First, we have a tactile vest that vibrates to alert the driver of speed regulation and emergency stop. Audio cues are used to give turn-by-turn direction to the driver regarding navigation. We also have a pair of gloves called Drive Grip that have vibrating motors on the top of each of the fingers to give information regarding steering. Finally, we wanted to create an interface that was much more informational as opposed to instructional, and we also wanted the driver to be able to make their own driving decisions. Therefore, we created a system called AirPix. An AirPix is a plate with a grid of orifices that uses compressed air to portray a refreshable map to the blind driver.
So we have all these interfaces and sensors and actuators. We needed a way to bring it all together onto one common hardware and software platform. For that, we chose the National Instruments Compact Rio. We chose the Compact Rio for its ability to provide the connectivity to the wide variety of hardware in our system. Additionally, we used the FPGA target on the Compact Rio to provide the high-speed acquisition, processing, and control necessary to function in the high-speed and time-critical driving environment. Now, finally, our team consisted of solely undergraduate mechanical engineers, so understandably, we had little to no experience in any specific text-based programming language. However, thanks to the intuitive graphical programming interface of LabVIEW FPGA, it allowed us to quickly progress from learning embedded design to deploying a blind driver in this vehicle in just 4 months. Now, we did bring along one of the many interfaces that we use to present the information to the driver non-visually and allow them to interact with their environment. And Ray, if you want, you can hop in the driver's seat here.
All right.
Get your hands and ears on some LiDAR data. So what you'll be doing is performing some basic obstacle detection. And Dr. Hong, why don't you act as our obstacle today?
Oh, you want me to be the obstacle? Okay. The things I'll do for science.
Okay, so Ray, all you need to do is put on that blindfold. You'll be paying attention to the feedback in the headphones and interacting with the system with that stylus on the touchpad on the right console.
Don't worry, Dr. Hong. I'm a very good driver.
So, as you see, on the top left, you'll see an image of the perspective of what a sighted driver may see. Directly below that is data correlated from the LiDAR that Ray's actually interacting with the touchpad.
There he is.
You found him. Now, as he scans on the touchpad, he's getting audio feedback in terms of an audible click track that varies frequency based on the proximity to that obstacle that he's looking at. Now, when he's ready, he can press a button for an on-demand audio cue where the FPGA will actually talk to him and tell Ray how far away he is.
So, Ray, you probably now know why we have Braille on a drive-up ATM machine, right?
Yes.
Thanks, Ray.
Now, as you can see, the involvement of NI technology has allowed us to design, prototype, and deploy the world's first vehicle to be safely and independently operated by a blind driver. Now, through this design project, we were able to create a great partnership with the National Federation of the Blind. And through this partnership, we gained access to dozens of blind drivers who were able to test out our interfaces, give us feedback on the interfaces, and also allow us to create those interfaces not only for the blind, but also with the blind. Now we have a special guest with us today who is one of history's very first independent blind drivers. He's also the executive director of the National Federation of the Blind Jernigan Institute, and he's here today to tell us a little bit more about blind driver from his perspective. Let's welcome Mark Riccobono.
Thank you, Kimberly. Appreciate that. Innovation can occur only at the intersection where a seemingly impossible problem meets imaginative thinkers who have an unwavering belief in the human spirit. The National Federation of the Blind established the Blind Driver Challenge, an attempt to solve a seemingly impossible problem, out of an unwavering belief in the capacity of blind people, a resource frequently underestimated. The fact is, today, society expects very little from blind people, and when you start from the perspective that little is possible, it is impossible to get more than little accomplished. Our vision for the future is more bold and imaginative. In a symbolic sense, the blind are shooting for the moon. The Blind Driver Challenge is the great quest for innovation, a quest to take full advantage of the untapped capacity of people. The innovations from our work will benefit us, but they will also benefit you. One day, we will reflect upon our speculation that the blind will drive as the innovative pattern of thought that created tremendous spin-off benefits for all of society. The NFB Blind Driver Challenge is a powerful example of what new applications of technology need to be pursued, why we must inspire and engage more individuals to be engineers, and how to create innovation. Until we found partnership with the team at Virginia Tech, only the blind believed in the vision of the NFB Blind Driver Challenge. The workhorse technologies of National Instruments and the innovative thinkers behind those technologies are now contributing to our quest. We invite you to join in our vision and contribute to our quest. If you strive to do nothing less than change the world, empower people, and find practical applications of knowledge to expand the horizons of our society, come, join with the National Federation of the Blind, Virginia Tech, and National Instruments, and together we will drive into the future. Thank you.
All right. Thank you, Mark.
Thank you. Appreciate it.
Thank you, guys.